Without objection, the chair is authorized to declare recess at any time. Good afternoon, and welcome to today's hearing entitled, The Future of Forecasting, Building a Stronger U.S. Weather Enterprise. I would like to welcome and thank all of our witnesses for being here today to discuss the important topic of the U.S. weather enterprise and how we can leverage the partnerships between the sectors to improve U.S. weather forecasting and modeling capabilities. The U.S. weather enterprise is one of the most robust globally, with NOAA estimating the value of weather data across all industries in the U.S. at approximately $13 billion in 2012. This enterprise is built upon open communication and collaboration between its public, private, and academic sectors. Americans across the country rely on data and services NOAA and the National Weather Service provide every single day. This freely available data serves as the basis of many of the consumer-facing weather products we regularly interact with, ranging from weather apps on our phones to the local forecasts on our TV news. This is a prime example of the strong existing partnerships between the public and private sectors of the enterprise. This freely available data is also the foundation of much of the research conducted in the academic sector that feeds into operations at the Weather Service. We've spoken in this committee about the increased frequency of severe weather events that are impacting every part of the country. In fact, NOAA has found that since 1980, the U.S. has experienced almost 250 weather and climate disasters in which the overall cost and damages have reached or exceeded $1 billion. A little over 2 weeks ago, Dr. Jacobs testified before this committee on the NOAA fiscal year 2020 proposed budget, where he informed the committee that the U.S. was not the global leader in weather forecasting. This is something that should be of concern for all Americans, given the need for accurate forecasts due to the wide range of severe weather events we experience as a nation and the increasing frequency of severe weather events due to climate change. We've also discussed the need to accelerate research and operations at NOAA, but in no place is that more crucial than at the Weather Service as it relates to improving U.S. weather models and forecasts. However, NOAA's budget request does not reflect this critical need, with more than 40% reduction in funding for the Office of Oceanic and Atmospheric Research, where much of NOAA's internal research is conducted and extramural research is funded. I hope to better understand how NOAA and the Weather Service plan to address the significant research to operations challenge in light of the priorities articulated in this most recent budget request. I'm looking forward to this hearing, starting the conversation about strengthening the enterprise, and I'm pleased to have representatives of all three sectors here today. While the private sector is perhaps the most diverse of the three, we are fortunate to have Mr. Rich Sorkin, CEO of Jupiter Intelligence, testifying from the commercial perspective. Jupiter provides climate and weather risk analysis based on NOAA and other federal and private sources of data. I would also like to welcome Dr. Shuyi Chen, whose research at the University of Washington is focused on understanding extreme weather events like hurricanes and depends on federal grants from agencies like NOAA. With the Atlantic hurricane season starting on June 1st, I'm glad she's here to answer any questions about hurricane forecast improvement. I'm also glad to have the opportunity to discuss an issue facing the enterprise, particularly NOAA, regarding the potential loss of our nation's valuable weather data from interference from 5G operations at the 24 gigahertz band. I look forward to asking Dr. Jacobs for more clear-cut answers to what these impacts will be, the cost to the American public, and how NOAA is working to mitigate these impacts. I am entering into the record a letter from the Aerospace Industries Association in support of this hearing and the importance of addressing the 24 gigahertz issue. So ordered. The weather enterprise is a dynamic entity that continues to evolve. Given how rapidly our technological capabilities are advancing, it is clear that we need to revisit the interaction between the sectors of the enterprise and understand how to best utilize these scientific and technological advancements for public good. That's why today's hearing should be a good opportunity to not only understand the current state of our weather enterprise, but how the three sectors of that enterprise can work together towards a common goal. Thank you. I will now recognize Ranking Member Lucas of the full committee for his opening statement.
Thank you, Chairwoman Fletcher, for holding this hearing. As I stated in the NOAA budget hearing, weather forecasting is among the most important matters in this committee's jurisdiction and one of our top priorities in Congress. We rely on accurate weather forecasting for everything from efficient crop planting to protecting life and property. From hurricanes to wildfires to tornadoes, we have an obligation to provide our citizens the most accurate information on weather events so they can make informed decisions for their own well-being. Weather forecasting is especially important in my home state. Two of Oklahoma's finest universities, Oklahoma State and the University of Oklahoma, have long histories of researching weather patterns. The National Weather Center is based in Norman and is a national leader in researching climate and weather. This year marks the 25th anniversary of the creation of Oklahoma's Mesonet, founded as a partnership between the University of Oklahoma and Oklahoma State. The Mesonet consists of a series of environmental monitoring stations that provide data to customers across the state of Oklahoma. Our Mesonet is a valuable climate tool and enjoys broad public support. I believe the Mesonet can serve as a model for improving forecasting across the nation, and I look forward to discussing this with our witnesses. This committee has a bipartisan history of weather research and forecasting policy. During the 115th Congress, we passed the Weather Research and Forecasting Innovation Act. This legislation provided NOAA important tools to help address its sub-seasonal and seasonal forecasting abilities by partnering with the private sector to collect weather data and integrate it into the forecast. More recently, Congress passed the National Integrated Drought Information System, known as NISDIS. The reauthorization built on previous efforts to help monitor and predict droughts and attempt to mitigate those effects. While Congress has taken steps to improve weather forecasting, we must be certain that other policies aren't undercutting our abilities. We've heard concerns about from NASA and NOAA about the recent FCC wireless spectrum auction could potentially undermine the quality, of weather forecasts due to the overlap of frequencies used to detect moisture. We all support the many benefits of 5G, including faster and more reliable connections, but we must develop it in a way that doesn't lower the quality of our satellites' remote sensing abilities. I hope the FCC will work to address concerns raised by the science community. I want to thank our witnesses for sharing their expertise today. We have a panel of government, private sector, and academic witnesses whose perspectives should inform this committee's actions moving forward. In closing, let me state that working towards improved weather forecast will be a top priority for me in this Congress. While we have made progress in improving the accuracy of weather forecasting, many challenges remain. This committee should be a leader in helping the federal government, the private sector, and the academic community pool its resources to take the next step in continuing American leadership in weather forecasting. With that, Madam Chair, I yield back.
Thank you, Mr. Lucas. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. Our first witness, Dr. Neil Jacobs, was confirmed as the Assistant Secretary of Commerce for Environmental Observation and Prediction in February 2018. He's been performing the duties of Undersecretary of Commerce for Oceans and Atmosphere since February 2019. Prior to joining NOAA, Dr. Jacobs was Chief Atmospheric Scientist at Panasonic Avionics Corporation. He was also previously the chair of the American Meteorological Society's Forecast Improvement Group and served on the World Meteorological Organization's aircraft-based observing team. Dr. Jacobs has a bachelor's degree in mathematics and physics from the University of South Carolina and a master's and doctoral degree in atmospheric science from North Carolina State University. Our second witness from NOAA, Dr. Louis Uccellini, serves as the Assistant Administrator for Weather Services and the Director of the National Weather Service. Prior to this position, he served as the Director of the National Centers for Environmental Prediction for 14 years, where he directed the operations at 9 INCEP centers. Before that, Dr. Uccellini has been the Director of the National Weather Service's Office of Meteorology, Chief of the National Weather Service's Meteorological Operations Division, and Section Head for the Mesoscale Analysis and Modeling Section of the Goddard Space Flight Center's Laboratory for Atmospheres. Dr. Uccellini received his Ph.D., Master's, and Bachelor's of Science degrees in meteorology from the University of Wisconsin-Madison. Our third witness, Dr. Shuyi Chen, is a professor of atmospheric sciences at the University of Washington. Her research focuses on understanding extreme weather like hurricanes and intraseasonal variability that affect the global weather and climate system and improving their prediction. Dr. Chen has led national and international research programs in both field observations and coupled atmosphere ocean modeling. Currently, she serves as the Vice Chair of the National Academy's Board on the Atmospheric Science and Climate. She received her Ph.D. in meteorology from Penn State University, her Master's in meteorology from the University of Oklahoma, and her B.S. in geophysics from Peking University. The last witness that I will introduce is Mr. Rich Sorkin, the co-founder and CEO of Jupiter Intelligence. Jupiter provides data and analytic services to better predict and manage risks from weather and sea level rise, storm intensification, and changing temperatures caused by medium to long-term climate change. Mr. Sorkin has been involved in Silicon Valley startups for 3 decades, commercializing technologies in a wide variety of industries. Mr. Sorkin received his MBA from Stanford and his bachelor's in economics from Yale. The chair will now recognize Ranking Member Lucas to introduce Dr. Christopher Fiebrich, who hails from his home state of Oklahoma.
Thank you, Chairman Fletcher, and I'm pleased to welcome Dr. Fiebrich to our panel of witnesses today. Dr. Fiebrich is the Executive Director of the Oklahoma Mesonet and the Associate Director of the Oklahoma Climatology Survey of the University of Oklahoma. He oversees all activities of the Mesonet, ranging from sensor calibrations to research. Dr. Fiebrich has published 26 peer-reviewed articles on Mesonet activities and research in his career. His Oklahoma roots run deep. He has a bachelor's degree, a master's degree, and a Ph.D. from the University of Oklahoma. So thank you for being here today, Doctor. Yield back.
Thank you, Mr. Lucas. Each witness will have 5 minutes for their spoken testimony. Your written testimony will be included in the record for the hearing. When you've completed your testimony, we'll begin with questions. Each member will have 5 minutes to question the panel. We'll begin with Dr. Jacobs.
Chairwoman Fletcher, Ranking Member Lucas, and members of the committee, thank you for the opportunity to testify today. Accelerating advancements in NOAA's global forecast system is a top priority. The future of forecasting in the U.S. weather enterprise is dependent on the success of this program, as this model serves as the underpinning for the majority of products and services offered by the National Weather Service and our industry partners. A skillful global weather prediction system is based on 3 main components: observations, code, and high-performance computing. NOAA is embracing new and novel in situ observing systems such as smartphone pressure, as well as commercial aircraft and ship data. Many of these valuable observations are obtained from industry, academia, and state partners through the National Mesonet program. The commercial weather data pilot has proven successful, and NOAA is now planning to acquire GPSRO data for operational use. Satellite data are the most critical inputs we have, and the polar orbiting passive microwave sounders account for 90% of the data used in the global model and provide up to 30% of the forecast skill. How the observations are used in the model is based on the code. The upgrade to the FE3 GFS is tentatively planned for mid-June. Future critical advancements are focused on model physics and data assimilation. As part of the input quality control, as well as enhancing subgrid scale output, NOAA is exploring cutting-edge artificial intelligence techniques. To meet these objectives, NOAA plans to harness external expertise across the weather enterprise, from industry software engineers to university faculty and students. By standing up an outward-facing community model development program through the Earth Prediction Innovation Center, which was authorized in the National Integrated Drought Information Systems Reauthorization Act of 2018. Based on the Weather Research Forecasting Innovation Act of 2017, EPIC will serve as the hub for building and maintaining a true community model. EPIC will significantly enhance our ability to access external expertise across the weather enterprise and place the global modeling program on a path to regain U.S. leadership as directed by the NIDIS reauthorization of 2018. None of this sophisticated code can be developed, tested, or run without substantial HPC resources. On the operational forecasting side, NOAA has a 99.9% uptime availability requirement with mirrored parallel systems that can fail over seamlessly to meet mission-critical needs of severe weather forecasts. The National Weather Service is often compared to the European Center of Medium-Range Weather Forecast when it comes to model skill and HPC resources. While we do have comparable systems, the European Center only focuses on a single global modeling system, whereas the National Weather Service runs dozens of models to address a wide range of issues, from weather and climate to short-range convection, hurricanes, ocean waves, air quality, storm surge, inland flooding, solar activity, and space weather. Transitioning research to operations requires a significant amount of HPC. One option NOAA is exploring is cloud-based virtual HPC provided by commercial cloud vendors. The potential public-private partnerships can solve a wide range of problems, from limited availability of internal research compute to providing systems that are accessible to the external model development community throughout the weather enterprise. Pilot programs within NOAA's Satellite Division, or NESDIS, have shown that the pre-processing of critical satellite data can be performed securely and reliably within these cloud-based architectures. By moving the processing to the location of the data, the potential exists to extract more value from existing satellite observations. Likewise, initial testing show that running the global model code in the cloud can offer a technically feasible and cost-effective alternative to internal HPC needed for research and development. Finally, NOAA's Big Data project has proven that commercial cloud-based storage is an extremely cost-effective solution for hosting and disseminating petabytes of environmental data. Making NOAA's data more easily accessible to the American public will create a substantial untapped opportunity for academic research and economic growth. Thank you again for the opportunity to testify today. I would be pleased to answer any questions you may have.
Thank you, Dr. Jacobs. Dr. Uccellini?
Good afternoon, Chairwoman Fletcher, Ranking Member Lucas, and members of the subcommittee. And thank you for inviting me to this very important hearing. It's come at the right time. Our nation is experiencing an increase in and impacts from extreme weather events such as devastating wildfires and floods, heat spells, snow and ice storms, tornado outbreaks, and catastrophic hurricanes. All of these events are well forecast and have been well forecast days in advance by the best forecasters in the world, the men and women of the National Weather Service. Weather Service forecasts execute their daily mission by working with emergency managers and other decision makers at all levels of government. They do this through a process called Impact-Based Decision Support Services that connects our forecasters directly to decision makers, communicating critical information so they can prepare a community in advance of extreme weather and water events to save lives and mitigate property loss. Decision support is a major component of our updated strategic plan that envisions building a weather-ready nation to ensure communities are ready, responsive, and resilient in the face of upcoming extreme events. This plan is embraced by our workforce, who now incorporate decision support into their daily work. The vision is also embraced by a large component of academic, research, and private sector components of the Weather Prize, as reflected by the growing list of 9,300+ weather-ready nation ambassadors, organizations all working with the National Weather Service to achieve this formidable goal. Executing our mission requires a comprehensive forecast process that begins with global observations, as you've just heard, processing those data, running weather, water, and seasonal climate computer models on supercomputers, forecasters applying their expertise and training to use that information to develop accurate forecasts and warnings, disseminating the information, and then supporting critical decisions made by our core partners. Underpinning all of this work are many research and development activities and the critical facility infrastructures that support advancing the Weather Service to stay at the top of our operational capabilities, for we are only as strong as our weakest link. We are pushing the limits of scientific understanding of the interactions of space, atmosphere, oceans, land, hydrology, and ice. More research needs to be done to understand how these Earth system elements interact to enable us to improve our model-based predictive capabilities of weather and water from the short term to the seasonal time frame. Our partners have told us that communicating and delivering consistent and accurate forecasts to them is key. To facilitate consistency and allow our forecasters to work more with decision makers, we are developing a new tool called the National Blend of Models. This tool will combine the best aspect of over 170 national and international forecast model members at any one time to produce a blended 7-day forecast. The goal of the MBM is to serve as a scientifically valid common starting point to drive more accurate and consistent forecasts across the nation. Disseminating our environmental information internally and externally is critical to making the entire weather and water enterprise function. We established the Integrated Dissemination Program to transform the organization's communication capabilities into an integrated, common, operational service with 100% backup capability for the first time in the history of the Weather Service. Data delivery services were upgraded, and the bandwidth to all Weather Service offices and external users increased tenfold. The level of demand on this system has far exceeded what was anticipated and is now reaching its maximum capacity as user demands continue to grow. We need to continue system and infrastructure enhancements to ensure future capacity and reliability meet these additional user requirements. Hiring expert forecasters and other critical operational positions is a top priority for us. Through a focused program of policy and programmatic innovations, we have turned the corner. Calendar year 2018 was the first year in nearly a decade that hiring outpaced attrition for that year. In summary, moving forward depends on fundamental advancements across a full spectrum of activities, including our forecasters embracing decision support, the Weather Service engaging the private sector across the entire value chain, advancements in science and technology, improved partnerships with academic research and the broader research communities that reach across many disciplines in the physical and social sciences, transitioning these research activities into operations. As directed by the 2017/2019 Weather Act, the Weather Service is evolving to provide more than just weather and water forecasts and warnings. It is also providing decision support services for federal, state, local, tribal, territorial emergency managers and water resource managers. Emergency managers have told us that their partnership with us has revolutionized the emergency management community from one that reacts to events to one that proactively prepares and stays ahead of extreme events. I am proud of the National Weather Service, especially our people who are on the front lines delivering critical products and services every day to help keep our citizens safe. We have come a long way, but there's more we need to do for communities to be ready, responsive, resilient for the next event, to be a weather-ready nation. Thank you.
Thank you, Dr. Uccellini. Dr. Chen?
Chairwoman Fletcher, Ranking Member Lucas, and all other committee members, thank you for the opportunity to testify today. Based on the questions from the committee in my invitation to testify, I organized my testimony around 4 topics: building a stronger U.S. weather enterprise and working toward a common goal, enhance national forecast capability, and meeting workforce need to support the national forecasting capabilities. And finally, we would like to chart a way forward for the U.S. weather enterprise. So, accurate, actionable weather forecasts and warnings can help save lives and reduce economic loss. Over the past 2 decades, weather research have enabled tremendous progress in better understanding weather process, advancing our ability to observe and predict weather. Atmosphere scientists of the United States among the best in the world. However, the United States no longer leads the field of numerical weather prediction as documented clearly by a number of National Academy reports. I believe that we have the ability to fully realize our potential in weather forecasting, be the best in the world. We must first understand the challenges we're facing so we can identify our weakness, find a solution, making progress. We need to build a strong U.S. weather enterprise working toward a common goal. So I applaud the committee for taking such important issue and having this address this issue in today's hearing. So as I projected on the screen, you can see the weather enterprise is complex, has changed significantly over the past 15 years, and continue to evolve rapidly. We're facing challenges to meet the growing need for weather and climate information in the society. To address these challenges, we first should recognize we have some specific things we need to do. For instance, model development. We need weather forecasts with long lead time. Weather knows no boundaries. What happens over the Indian Ocean and the Pacific Ocean can influence rainfall and flooding, heat wave, drought, and the potential for wildfires in the United States on timescale of weeks to months. So to predicting these phenomena, we will need to represent the slow varying part of the Earth's system, ocean, land, and the sea ice in our weather forecasting model. On the other hand, impact of weather is all very local. Hurricane Harvey, Irma, and Maria showed us very clearly we need the level of forecast detailed down to the streets for street level for storm surge and flooding, and that aid for the decision-making like emergency management and the electrical grids and the infrastructure, and for recovery process as well. The other challenge we have is the research to operation is unmet challenge. We have tried to communicate it for many years now. That remains to be a problem because many of the research product has no pathway go into operation as we know today. So advancing technology and such as high performance computing, cloud-based computing, artificial intelligence, new observing capability and communication capability present a number of opportunities for us to really meet these challenges of the system. So in order to move forward, I would like to see the uncoordinated enterprise as we see in the top left toward enterprise that works toward a common goal. To do that transition, from my perspective, I would have a few recommendations. One, we would like to see to launch a study by the national academies on the future of the weather enterprise. This study can help us to assess the current state of the enterprise and the way forward with experts from all different areas. We need to develop a national unified modeling system to address the entire time scale, cross scale from the longer time lead time to the high resolution local forecast. To do this, we need a consolidated national center with participation from the entire weather enterprise and multi-agency support. And we would also like to establish for a sustained resources to support research, observation, communication, modeling, computing, forecasting, and workforce development. So in closing, I think there's no doubt that improving weather forecast and response to save life and reduce economic loss should be a national priority. Restoring U.S. leadership in weather forecasts for benefit of society is a great challenge. No single federal agency, no single private industry, no single university can do it alone. It will take the entire weather enterprise. Thank you for inviting me, and I would welcome to any question you may have.
Thank you, Dr. Chen. Dr. Fiebrich?
My name is Chris Fiebrich, and I'm the Executive Director of the Oklahoma Mesonet, and I'm also adjunct faculty in the University of Oklahoma School of Meteorology. and I want to thank Chairwoman Fletcher and Ranking Member Lucas and the members of the committee for the invitation to speak to you today. The Oklahoma Mesonet was established 25 years ago, both to address the needs for improved severe weather warnings and to improve our ability to research and better understand the weather. We have one or more stations in each of our 77 counties so that no matter where you are in Oklahoma, we have local real-time observations within about 10 miles of your location. The power of any Mesonet is driven by the high spatial density of its observations. And the goal of our Mesonet is to provide timely and useful weather information to Oklahoma citizens and decision makers. The Mesonet is a unique partnership between our state's two largest universities, the University of Oklahoma in Norman and the Oklahoma State University in Stillwater. Our operational home is at the National Weather Center on the OU campus, where we share space with OU's School of Meteorology and 5 NOAA facilities. This gives our students the opportunity to work side by side with NOAA's Storm Prediction Center, the National Weather Service, and the National Severe Storms Lab, providing unique benefits to both the students and the Weather Service. 2 additional OU research centers that stand out with regard to their engagement with the Weather Service are the Advanced Radar Research Center and the Center for the Analysis and Prediction of Storms. These centers are actively developing the prototypes for the next generation of weather radar systems and testing new weather models and forecast delivery systems in NOAA's Hazardous Weather Test Bed. My primary expertise is the Oklahoma Mesonet, which I oversee at OU. When the Mesonet began 25 years ago, we knew we'd fall short of our potential if all we did was collect the weather observations. We knew we needed to synthesize the data into useful tools for our citizens, first responders, and the state's key economic sectors. In the area of fire forecasting, we've trained more than 1,600 wildland fire managers on weather's impact on wildfire suppression, prescribed burning, and smoke management. Many aspects of wildland fire behavior can be modeled with real-time Mesonet observations, including predicting the likelihood a fire will ignite, how fast it will spread if it ignites, and how high the flames will be given the observed winds, temperature, solar radiation, and moisture. Mesonet data are also used to improve production and optimize inputs for crops and livestock. The occurrence of many plant pests and diseases can be successfully predicted given observations of mesoscale weather conditions. Using the latest agricultural research, coupled with real-time Mesonet observations, allows growers and producers to make efficient decisions on spraying for pests and diseases, as well as smart irrigation decisions. While Mesonets like the one we have in Oklahoma provide significant value to numerous economic sectors, the greatest value that weather observations and prediction systems provide is for protecting lives and livelihoods. We've trained over 1,400 emergency preparedness managers, police, fire, and public health professionals to use our data to keep Oklahomans safe. Oklahoma, as you know, is subjected to many forms of destructive weather, most of which occur on the very short time scales of minutes to hours. These are threats that include damaging winds from thunderstorms, flooding rains, and crippling ice storms. The Oklahoma Mesonet has proven its worth in this role by significantly advancing the special form of forecasting known as nowcasting. Nowcasting is the prediction of critical weather details in the next 0 to 6 hours that are often difficult to resolve through numerical weather prediction models. Subtle atmospheric features revealed by the Mesonet show the locations of fronts, dry lines, and moisture plumes that allow Weather Service forecasters to pinpoint areas most likely for convective initiation. On the national scale, the Oklahoma Mesonet is part of NOAA's National Mesonet Program, comprising 30 such university and state Mesonets and additional partners. The National Mesonet Program has proven to be a successful public-private partnership model in which the federal government can leverage tens of thousands of additional real-time weather observations from across the nation without having to maintain and operate them. This allows forecasters to use these additional data to improve weather models and thus every community's weather forecast. It's essential that Congress and the administration support and expand the National Mesonet to ensure that local forecasters have access to these highly localized weather data. The university is proud to play a role in these programs, and I look forward to answering any questions you have about our efforts in Oklahoma.
Thank you, Dr. Fiebrich. Mr. Sorkin?
Chairwoman Fletcher, Ranking Member Lucas, and members of the subcommittee, I am Rich Sorkin, CEO of Jupiter Intelligence. Jupiter predicts risks from weather and climate change. We work with some of the country's and world's largest insurance, mortgage, power, and resource companies responsible for roughly $1 trillion in assets, showing them the risks to their assets in their language and relevant timeframes. I appreciate the opportunity to testify before you today. I understand the committee is broadly interested in the weather enterprise, leadership in forecasting, the role of the private sector, and all of this against the backdrop of increasingly severe weather and impacts due to climate change. I have 3 core points. First, broad sectors of U.S. society are increasingly concerned about the growing risks to life, well-being, and property caused by climate change. The federal government should, among other things, do more on preparedness, especially in programs related to infrastructure investment and the Department of Defense. Events such as Hurricane Katrina, Superstorm Sandy, Hurricane Harvey, Midwest flooding, and the California wildfires dramatically illustrate the need for improvement in planning for, predicting, communicating, and reducing the risks from extreme weather. Costs for emergency response and disaster recovery, especially from FEMA, are increasing much faster than GDP or government revenues. Recently, the Air Force requested that Congress allocate $4.9 billion for repairs at just 2 bases, Tyndall in Florida and Offutt in Nebraska, from damages due to severe weather. And this is just the tip of the iceberg. The impacts of climate change are not just in the future, they are upon us and getting worse. And the risks are resonating in corporate boardrooms. Second, while NOAA and the National Weather Service do an excellent job of forecasting, they could do even better by using technologies widely adopted in the private sector, particularly artificial intelligence, or AI, and cloud computing. Jupiter, for example, is seeing enormous acceleration in transitioning research to operations through the use of cloud computing. These technologies assist in global collaboration both inside the company and with our university partners, and in rapid prototyping and accelerated performance testing. AI is also benefiting Jupiter in the spatial and temporal resolution of our predictions, the speed of developing new services, and reductions in costs for computing. China, by the way, is making enormous progress in AI. We need to ensure that we are not leapfrogged by China, both in the weather enterprise and more generally. The Earth Prediction Innovation Center, or EPIC, is an excellent first step in NOAA adopting AI and cloud computing. Third, the path to renewed U.S. leadership across the weather enterprise depends upon stronger collaboration between the 3 sectors of the enterprise. A vibrant private sector is emerging for solutions to help customers understand, plan for, and mitigate the impacts of severe and worsening weather. Investors have deployed billions of dollars in satellites, other observations, and analytics, including work like ours, and will invest more, especially if the collaborative relationship is right, with the federal government focusing on the core modeling that the private sector can build upon. At Jupiter, we have followed a collaborative philosophy from the beginning, working with the federal government and university partners. Going forward, I recommend enhanced investment in NOAA's capabilities to produce better weather forecasts, as well as expanded observations to help produce actionable climate risk services. While NOAA's role in saving lives and property is paramount, the private sector can supply hyper-local climate information to our colleagues in the private sector as well as local governments. I also recommend easing the way for public-private collaborations, as well as improved mechanisms for allowing pilot projects with NOAA, which could provide favorable returns on investment for the government and its agencies. I look forward to your questions. Thank you.
Thank you, Mr. Sorkin. At this point, we will begin our first round of questions. I'll recognize myself first for 5 minutes. And I'd like to start with Dr. Jacobs. When you previously testified before this subcommittee on April 30th, you said that the subject matter experts at your agency, NASA, and the FCC are collaborating on a study to set out bounds emissions limits on the 5G spectrum use at the 24 gigahertz band to prevent interference with weather data. You said on the record that the results of the study would be decided upon on May 15th. When will, a few questions, if you can just touch on these. When will the study be released publicly? What is the answer on an acceptable out-of-bounds emission limit to protect valuable federal weather data? And can you explain NOAA and NASA's analyses, including how much weather data would be lost and what would be the impact on forecast accuracy from emissions bleed over?
Thank you for the questions. I don't have an answer as to when the actual study will be released. I would like to say that NOAA and the Department of Commerce support 5G. We are dependent on 5G to be very successful in a way to distribute our tornado warnings faster to the public, and I'm optimistic that we can come up with an elegant solution where passive microwave sensing and 5G can coexist. That said, right now the input parameters that we are using in this study were provided by the International Telecommunications Union with input from industry. We subject matter experts in the FCC, NASA, NOAA are going back and forth, still debating the input parameters. I don't think there's any debate in the actual algorithms in the code itself. It's the input parameters. From what I've seen, any change to the assumptions and the input parameters proposed by the FCC that have some type of scientific basis produce a negligible change to the NOAA-NASA number. The number currently proposed by the FCC, minus 20 decibel watts per 200 megahertz, according to the study, would result in roughly a 77% data loss from our passive microwave sounders. This would degrade the forecast skill by up to 30%. So if you look back in time to see when our forecast skill was roughly 30% less than it was today, it's somewhere around 1980. This would result in the reduction of hurricane track forecast lead time by roughly 2 to 3 days. A good example of this is a data denial study that the European Center did where they withheld the microwave sounder data during the forecast for Superstorm Sandy, and the model, which is the most accurate model in the world right now, kept the storm out to sea. So it's incredibly important. It's a critical data set for us. The number that we've been dancing around is in the upper 40s, lower 50s, depending on whether you're discussing base stations or user handheld devices. This number would result in roughly 0 data loss, and then anywhere in between there, we're looking at data loss possibly large enough to prevent us from meeting our mission requirements with the future JPSS system.
Okay. Thank you, Dr. Jacobs. I have just a short amount of time, so I want to ask just more broadly to anyone who wants to answer this on the panel. As you all know, our economy is becoming increasingly reliant on accurate weather data for decision-making. Every American consumes weather data in their everyday life, and it's in the interest of the entire country to understand how the weather enterprise plans to move forward in improving the short, medium, and long-range forecasts and adapting the forecast to best serve all Americans and trying to understand how the weather will impact them. So whoever wants to touch on this briefly about the current mechanisms, can you talk about the current mechanisms for collaboration and communication between the members of the weather enterprise and how they could be improved? Anybody wants to take that up? Dr. Uccellini?
So I probably have had a long history in this, goes way back in trying to get agencies working together on this. I think we're in a good spot right now with respect to agencies recognizing that they have to work together to advance. This wasn't always the case. There was this divide between research who didn't want to adopt, let's say, the operational goals or have their results hung by an operational success when their success is measured by, papers they publish and the research that they. In fact, the Academy did a study on this, and they entitled the study, the Research to Operations, the Valley of Death. So, and I've tried reaching across that many times. I think there has to be is some kind of programmatic advances that a research organization, operational organization see value in the outcome to both. What's happening in the research community now, as Dr. Chen has, I think, illustrated quite nicely, is that they are interested in how we're moving forward to serve society. So now's the time, from a programmatic point of view, whether it's focused on types of events, broad scale from maybe seasonal down to the mesoscale, how we can move forward in that arena, this whole seamless suite of products that research community has put forward as a basis for getting researchers and operational people to work together that I believe are out there and want to do it.
Thank you, Dr. Uccellini, and I've exceeded my time, so I'm going to go ahead and recognize Ranking Member Lucas for 5 minutes.
Thank you, Madam Chairman. Dr. Jacobs, following up on the first part of the chair's series of questions in regards to spectrum and those resources, if NOAA is forced to stop work on its polar satellites, is there another type of observation that can offset that loss?
Not today. I can't say that one wouldn't exist in the future, but there's not an existing capability to mitigate that data loss that exists today.
So this really matters.
Yes.
Dr. Jacobs, I understand NOAA is still conducting the commercial weather data pilot program. Can you give us an update on the program, and is NOAA still considering purchasing commercial data?
Yes, with respect to the testing of the GPSRO data in our models, we're seeing a very promising impact. We've transitioned this over to actually in the proposed budget to acquire this data as an operational data source. The commercial weather data pilot program will actually look at additional instruments beyond GPSRO, perhaps hyperspectral sounders or other instruments.
Turning to you, Dr. Fiebrich, the Mesonet is a valuable resource which assists Oklahomans across the state in decisions ranging from farmers deciding when to plant, that soil temperature key being very important, to emergency personnel preparing for weather events. Can you describe to the committee what makes the Oklahoma Mesonet unique?
Thank you for the question, Representative Lucas. I think one of the big things that makes Oklahoma's Mesonet unique is that we have survived 25 years, because it is a great challenge for the state networks to find the funding to keep these networks going from year to year.
At least twice in my tenure in Congress, I've made calls home to I'm a former state legislator, calls home to my old friends about how important this is over the course of the last decade. Absolutely. Do you think we could replicate this model on a larger scale to provide the kind of weather forecast thing that we do in Oklahoma?
Certainly. Once we developed the Mesonet in Oklahoma, others took notice. They saw the dividends we were bringing to Oklahoma. And over the years, we've worked with 25 states and countries to help them plan and operate Mesonets in their regions across the U.S. Because, as Dr. Chen mentioned, the weather doesn't stop at boundaries, at state boundaries. We need those observations in neighboring states like Texas and Kansas and Colorado to help make predictions in Oklahoma also.
In my home community, we're, of course, on the east side of the Rockies, southern plains, the western part of the state, as you well know. Prescribed burns are a very important part of maintaining the ecology of the national grasslands. My colleagues here who have not had a chance to look at your website would be amazed at the information that the Mesonet provides, and literally no prescribed burn plan in Oklahoma starts without a requirement to examine on a moment-by-moment basis the Mesonet sites before you can move on. That said, in your role as Executive Director of the Mesonet and a faculty member at the University of Oklahoma School of Meteorology, you're uniquely positioned to offer testimony to this committee about the collaboration between federal, academic, and industry. In your experience, is there enough collaboration between the different components of the weather enterprise? And for that matter, what actions could this committee take to promote a more effective collaboration, Doctor?
Well, as I mentioned, the National Mesonet program that I've been able to witness, I think, is a perfect example of that public-private partnership, that cost-sharing model where you can take the expertise of the universities at the state level, work with the private sector, and provide the federal government tens of thousands of additional observations at a fraction of the cost. I think specifically this committee could help promote that collaboration by steady growth of the program, supporting the program, because as we have more observations, the forecast will improve. As there's more support, it'll give researchers the opportunity to look into new technologies and Mesonets. I think a really exciting one is using UAVs. We've launched over 1,000 UAVs at our Mesonet sites in prototype mode to look at how that could provide observations of the lower boundary layer to provide to Weather Service forecasters.
Thank you, Doctor. Just one more time, Dr. Jacobs. Let's go back for a moment to the polar satellites. At the present time, if we lose the ability to use those, there's not another resource of that nature at the present time available to replace them with that
No,
consistency.
we have no other capability to passively observe water vapor.
Thank you. Yield back, Madam Chair.
Thank you, Mr. Lucas. I'll now recognize Mr. Tonko for 5 minutes.
Thank you, Chairwoman Fletcher, and thank you to the witnesses for being here today. I am deeply concerned about the reorganization of the National Weather Service forecast offices. My questions about EVOLVE have faced delays, misinformation, and many questions remain unanswered. I've been requesting some of this information since May of 2017, so let me state the obvious. That was 2 years ago. These delays have only added to my concern about what's really going on at the National Weather Service. At various times, I've been given contradictory and sometimes clearly incorrect information and reasoning for the delays, and at times I have received no answer at all. Lacking a consistent, credible response, I have to think that where there's smoke, there is indeed fire. And there has been an awful lot of smoke these past few years. This prolonged pattern of misinformation and evasion leaves me wondering, what is the agency hiding? So, Dr. Uccellini and Dr. Jacobs, I'm looking for a straightforward yes or no. Will you commit to providing members of this committee with all of the materials that have been requested?
Yes.
And Dr. Jacobs?
Yes.
And can I ask what date would be a reasonable date by which to receive that information?
We'll have to get back with you on the exact date because that depends on the actual materials that we have to gather, but it'll be as soon as possible. I can promise you that.
Well, if you could get back to the committee and at least give us a date in the very, very near future.
Certainly.
So that we can understand what that threshold date is. Section 410 of the Weather Research and Forecasting Innovation Act of 2017 required the agency to submit a report on contractor use and the number of civil service vacancies at the NWS by October of 2017, and to publish an annual report on the Internet within 6 months of the end of every fiscal year thereafter. Your agency has missed both deadlines. Why have you not submitted and published this report, and when will you do so?
So we keep track of the level of positions we have that are appropriated for and the number of positions that we have on a bi-weekly basis. So I'm a little bit confused as to why those numbers haven't gotten up. But as of right now, we are appropriated for 4623. On board is 4194, which is 429 vacancies. And we have over 300 hiring actions in place right now.
Thank you. And Dr. Jacobs, I expressed to you the last time you were here that I also have some major concerns about National Weather Service understaffing. I'm especially concerned that any reorganization or reduction of hours not result in any degradation of service. For example, I recently learned that the proposed changes to how you categorize field meteorologists will in fact result in fewer forecasters in each office. That is not acceptable. The rushed implementation of the National Blend model with the purported goal of freeing up forecaster time is concerning. The background of all this makes matters even worse. NWS is not filling filling critical vacancies. Let me be very clear. If you are defying Congress and the American people by using this process to diminish the capacity and numbers of our forecasters, Congress will not be silent. Any major transition of this kind needs to follow a process backed by research and evidence that show the change will not degrade service. Some of the new innovations here are great forecasting tools, but they cannot replace having enough experienced forecasters on the ground. I've heard from many forecasters who are worried about the hasty changes being made and about the resulting negative effect that this will have on public safety. Their concerns are credible and deeply disturbing. Based on what we already know, the committee needs to hear directly from forecasters on the ground as well as emergency service providers who rely on them. I am nearly out of my time here, Madam Chair, but again, I would hope that we can work together on this going forward, because there are important constituencies who we should hear from, including the people who work as forecasters at the National Weather Service, and from the state and local workers and emergency workers who work closely with NWS to keep our constituents safe. This is a critical service. As a person who chairs the Subcommittee on Environment and Climate Change, there is a direct link. And I want to make certain that we're utilizing professionalism to the nth degree and in the most effective and efficient manner. So with that, I'll yield back.
Thank you very much, Mr. Tonko. And I would just like to underscore the importance of providing the documents that Mr. Tonko has requested, and of course, providing all documents as they are requested by members of Congress. Thank you very much. I will now recognize Mr. Gonzalez for 5 minutes.
Thank you, Madam Chair. Thank you to the witnesses for being here today and for your attention and testimony. In my home state of Ohio, we have tremendous research institutions that are always at the forefront of innovation. And I want to turn my question to the role academic institutions play in weather forecasting. Dr. Chen, what role, in your opinion, should academic researchers play in helping the U.S. to improve its poor position in weather modeling? And can you tell us a bit more about how the institution should play more broadly?
Thank you, Mr. Gonzalez. That's a great question. We have been really wrestled with this question for a long time. Academia, we play important role in several fronts. First, the innovative research has been done at the university level and academia, broadly speaking, has always been the forefront in the world. And a lot of research product we're very proud of, eager to put them into useful tools for operations. This has been a unmet challenge that I have mentioned. Second, the academia have a key role to play for training the future workforce. The need for impact forecast and how people respond to forecast is very much interdisciplinary and multidisciplinary research. And these require our current workforce to be up to date in terms of both computing, management, and there's a lot of interface between physical science and the social science. We are very active in terms of promoting that multidisciplinary research education to prepare for the workforce to meet the challenge. So this part of the academic community really taking this very seriously. Although we still have a challenge, we would like to reform our system to meet the current technology and the science advances.
Thank you. And Dr. Uccellini, given we are in the cusp of new technologies being implemented across different applications and parts of our economy, I'm curious to know what you see the future role of artificial intelligence and machine learning at the National Weather Service. And Mr. Sorkin, if you could talk about it more related to your industry after he's done.
Well, I think it's going to have a major role, and there's a lot of potential in utilizing that to assist decision-making, both in terms of accessing the data and quality control, extracting information from numerical models, whether they're the single runs or the ensemble runs. In fact, it's no way possible for any human being to extract all the information out of the myriad of ensemble model runs that we access today. And then in the probability aspects, in terms of how you affect a decision at key decision points, I think it'll be helpful there as well. I do want to emphasize that all these systems are better utilized as they're assisting decision-making by a human being, and that's something that I think sometimes gets lost in the enthusiasm for artificial intelligence.
Absolutely. Mr. Sorkin.
Yes, Jupiter uses a combination of dynamical modeling, as is prevalent in the weather enterprise, AI, and other forms of modeling. One of the benefits of our cloud-based architecture or infrastructure is the ability to compare the results of a dynamical modeling and AI approach side by side in the same modeling chain. We essentially can substitute one, see how it performs versus the other, both in terms of the accuracy of the predictions when tested against ground truth data, the overall compute load, and the explainability of the results, which in certain regulated industries is also critical. And I would say that overall the private sector in most other domains is much further ahead, primarily because of the amount of investment in AI than the weather enterprise generally.
Got it. And then if you could, how do you feel we're doing relative to China on this particular front?
Specifically within the weather enterprise?
Specifically AI machine learning. So generally.
Historically, the United States has been a leader in AI and machine learning. The Chinese are catching up very rapidly. They have fewer constraints on the use of consumer data, which in some cases is an advantage in further progress. On the whole, I think the United States is still ahead. However, it's an area that definitely requires very careful attention by the federal government and the private sector on an ongoing basis. And in addition to that, I would emphasize the importance of protecting the country's intellectual property, something the president has given substantial attention to recently, and that is a critical issue for Silicon Valley and the country generally.
Excellent. Thank you, and I yield back.
Thank you, Mr. Gonzalez. I'll now recognize Mr. Christ for 5 minutes.
Thank you, Madam Chair, and thank you for the witnesses being here today. We appreciate your attendance. Dr. Jacobs, great to see you again and to have another opportunity to discuss the very critical work that NOAA does. Today's topic certainly is an important one, Madam Chair, and timely as well. We're only 16 days away from the start of the hurricane season. So when I heard weather forecasting would be the subject of today's hearing, my mind immediately went to Hurricane Irma, which, as you know, hit my home state of Florida in 2017. Leading up to that storm, the track kept shifting. First it was up the East Coast, then up the West Coast, and then finally straight up the middle of Florida. The entire state of Florida was inside the prediction cone, making it difficult for emergency managers to make evaluation decisions, and prompting a mass exodus of 7 million people from the state that clogged our roadways and stressed fuel supplies. And while I'm thankful that so many Floridians took the storm as seriously as that, some would argue that over-evacuation can prompt under-evacuation the next time a storm may hit. And that's something I'm extremely concerned about. Dr. Uccellini, how can we improve track forecasts for hurricanes to shrink the cone, perhaps, and provide the most accurate information to the public ahead of a large hurricane like Irma was?
So a couple of points on that. First of all, with Irma, we were actually amazed that the governor of Florida actually declared a state of emergency 6.5 days before landfall, recognizing, A, the uncertainty in the track forecast, and we try to communicate that, and especially with our users, we're embedded in the emergency operations centers and the like.
For the record, that was not me.
I know,
Okay.
I know. But it was an amazing event for us as well to have that happen, given the uncertainties between the tracks up the east coast of Florida and the tracks up the west coast of Florida. What we saw was that on either track there was going to be significant impact to the entire state. But you're pointing to a really major problem that decisions are made earlier to try to hit that sweet spot for the evacuations. And given that earlier need for decision-making, it puts extra emphasis on the need for model forecast because that's the only thing we have in those timeframes to base any kind of decisions, that 3, 4, 5, 6, 7 days in advance. To improve the models, it's all the things we're talking about here. You need the global observing network. So Dr. Jacobs spoke to the need for the passive microwave sounders, that any value study of observations into models that I've seen rates that as the #1 observation for the accuracy of the models. So you have observations, we have to improve the models in terms of resolution, the data assimilation to ingest the information for those models, and the physics, all of the above. And we continually need to press the computer industry for running models operationally. We have a primary system and a backup system so that it's always there. And we're always pushing the envelope on the computational capacity that we need to run an operational model system to ensure you're getting the best forecast on a timely manner all the time. So those 3 components are there, and we're working all 3 of them. Again, like I said before, we're only as strong as our weakest link. We're pressing ahead on all 3.
Great, thank you very much. And Dr. Chen, I'm curious, would you have anything to add to this?
Yes, I think Irma told us a lesson for current capability. We're not quite met the challenge of forecasting impact. So in hurricane forecast, we not only need the track to be correct, intensity correct, and also the tool to forecast storm surge. For instance, Irma, 18 hours ahead of Irma, the forecast for Tampa Bay area is greater than several foot of water. So you know what happened. Tampa Bay not only didn't get a storm surge, actually water drained out of Tampa Bay. We saw the bottom of Tampa Bay because wind offshore and water being pulled out of Tampa Bay by ocean currents. This is a demonstration that we need a coupled model with ocean and atmosphere and storm surge capability to make that level forecast. So that is a lessons we needed to learn. And at the same time, I do want to tell you that that morning, the BBC and the CNN called me about explaining this because we have a publication already described the full coupling impact on storm surge. So academic community do have research results where currently have no direct path to have that function in the National Weather Service at this stage. So I want to emphasize the point that we need a mechanism to make research to operation transition.
Great, thank you very much. My time is up. Thank you, Madam Chair.
Thank you. I'll now recognize Dr. Baird for 5 minutes.
Thank you, Madam Chair, and thank you, witnesses, and for your testimony and discussion of these issues about weather. But Dr. Chen, you mentioned the changing landscape of the U.S. weather enterprise and the challenges that's presenting. You also mentioned, just as kind of as an example, that these include the shifting balance between government and private sector. So I guess my question deals with this. What do you foresee, and could you prioritize those for the future needs of the U.S. weather enterprise, and how and what Congress might do to be able to facilitate that?
Thank you for the question. That's a great question. We've been wrestled with this for a long time. The weather enterprise is broad. We have both. We have 3 sectors: the government, and the private, and the academic. So, in fact, I want to go back to an example we just discussed: the 5G. The weather enterprise is broad. A lot of times, our challenge is even broader, because the 5G that actually showed us example, the weather enterprise interface with other sectors. So I think national academies have the capability to bring in all 3 sectors and outside of weather enterprise to really make this assessment where we are currently. For instance, this 5G issue, it is complex. We interface with a different part of the technology and economy. So National Academy now is planning to bring in the board on radio frequency, which is not within our current weather enterprise, but we are expanding that because the need for the society. So if I may, I would like to comment on how should we go forward of making this enterprise is so broad and excellent on each individual parts, but the total is not meeting up the sum of each component. The total should be better than the sum. So in order to do that, I really think we have opportunity to bring this into a new operating model that bring in the academic, private, with the government agencies, not only one agency, but multi-agencies, National Science Foundation, NASA, Department of Energy, Transportation, many of them can bring their expertise on the table to develop models, observing capabilities, computing assessment. That's another complex field that we have not been able to do full assessment, whether it's the high-performance computing or cloud-based computing or combination of many things. So our horizon really is looking down the 10 years, 20 years from now. So we need to be totally open, bring all the sectors coming to the table to design the system. And in order to do that, we need to have a national center to bring the entire community in. And developing this unified model can address this complex issue we just discussed, because we're facing the weather impacts local and the global prediction increase our lead time. These are huge challenges. Our current modeling system are not capable of doing this for the time being. If I may, I want to add one more component. So we all have our phones in front of us. The phone, I have my first iPhone 2007. Only a little more than 10 years, this technology has changed our entire society. We are looking in the weather enterprise in terms of next decade or 2 decades. We have to be completely open-minded, embracing all possible sectors to think broad and bold, and thinking that we may really need assessment now, and how do we anticipate what's happening next. Thank you.
You timed that very well. You used all my time, so thank you very much. Great, but a great answer, and we appreciate it. I yield back.
Thank you, Dr. Baird. I'll now recognize Mr. Byer for 5 minutes.
Thank you, Madam Chair, very much. Dr. Chen's clearly a seasoned testifier before Congress. So. Dr. Jacobs and Dr. Uccellini, it's often been the role of this committee to play defense on behalf of the staff, the workers of the National Weather Service. And I just want to make sure, echo Mr. Tonko's remarks, that we want to make sure that any reorganization of the reduction of hours don't result in a degradation of service. We'd like to work closely with you to make sure that that workforce that's so essential is treated fairly and is part of the solution. Moving on, I again, to Dr. Jacobs, Dr. Uccellini, I read really carefully your testimony about 85% of the data is water vapor data that you use for weather forecasts, and that due to the physical properties of water, water vapor can only be measured at the frequency bands currently allocated, the FCC's proposed radio frequency, We have apparently heard a great deal from the digital community, the AT&Ts and others, saying, no, this is not going to interfere with NOAA. Where's the science on this? And how do we respond to the FCC chairman's notion that there's no science to back up this idea there's a conflict with this 24 band and NOAA's need for the data?
Well, we've been working together with NASA and the FCC for the last couple of years on this study, and actually at the request of the FCC, we've reconducted this study multiple times. In fact, wholesale rewriting the software in MATLAB for a second time. I really don't think anyone's debating the actual algorithms in the study. The debate tends to be around the assumptions of the input parameters. And right now, we're using the input parameters that were provided from industry that meet the recommendations by ITU. So if there's other parameters beyond that, we would have to determine whether there's any scientific basis for that or not.
Is this the kind of thing that you would encourage Congress to take an active role in protecting the weather data and therefore pushing back on the FCC's intent to go forward?
Well, I haven't seen any scientific evidence to support the minus 20 decibel watt per 200 megahertz number. So right now, the only scientific studies I've seen out there are the ones produced by NOAA, NASA, which have been concurred with by the Navy, as well as an independent European Space Agency study, which actually concluded a more restrictive number than we came up with.
Okay, thank you very much. Mr. Sorkin, in Dr. Jacobs, Dr. Uccellini's testimony, they also talked about the availability of the unique data sets developed by the commercial sector, the private sector, could potentially jeopardize not only academic research, but also the market for specialized weather products and services. So I think they were trying to do the yin and the yang. On the one hand, we want to have all this data available to the researchers. On the other hand, what do you have left to sell? What's the private sector's perspective on the data sharing?
The private sector is a diverse and complicated entity. It's not one particular viewpoint. So for someone like Jupiter, we are consumers of the data from the federal government, and in particular NOAA and NWS, and it would be substantially disruptive to our business if some of that data and the modeling that NOAA does based on that data were no longer available. On the other hand, like Dr. Jacobs, we see that technologies like GPSRO are quite promising in improving the skill or overall performance of the weather forecasts. And so I would take a blended approach. It's kind of case by case. Certain data is of great value add to both NOAA and the private sector. Other data might be directly competitive. From our perspective, we kind of sit on top of that, and we'll use whatever the best available data is, whether it's coming from the federal government or the private sector. And that then translates into the best available services for citizens in places like New York and Houston and Puerto Rico and throughout the country in terms of understanding these risks. And we're really agnostic as to where the data comes from.
Great, thank you. And later, Dr. Jacobs, I'd love to explain to me cubing this sphere and how parallel that is to squaring the circle. But my time is up, so.
Thank you, Mr. Byer. I'll now recognize Ms. Gonzalez-Colon for 5 minutes.
Thank you, Madam Chair, and thank you, all the witnesses here. And coming from an island that suffered 2 hurricanes in a row, Irma and then Maria, I'm really grateful for all the help NOAA and the rest of the agencies gave to the island. Not just to the reconstruction, we lost our power, we lost our communication, we lost our radars, and we actually lost our Doppler, and that with the airport as well, with the radars at the airport. So it was because of the U.S. Marines radar units in the Department of Defense that were lended to us on a temporary basis for a few months, actually, I think 9 months until you got repaired, the Doppler and the radar. And we allocated funds for that during the bipartisan bill, plenty in different areas for repairing new technology and the sensors. My first question will be, all the Dopplers and the radars are repaired using new technology, or they were just repaired as they were before the hurricane?
So, first of all, thank you for your comments. We actually worked with the Department of Defense, and we're very thankful for the interaction bringing their X-band radars to you. And it was more than one, and we remind everyone you were still in the middle of the hurricane season when we were able to do that. And we got the Doppler reconstituted. In that process, we actually improved the receivers and the transmitted components of the radars. That was part of an ongoing effort for the Service Life Extension Program for all the radars in the United States. So we built that new technology in. but still operating on the same principles, including the inclusion of the dual pole, so.
Yeah, the reason I'm making this question is I remember we working with you guys and the rest of federal agencies to make that happen, and remembering when you use military planes to have the pieces to work that out. And when you got no raiders, no commercial planes flying to the island, no water, no electricity, and no telecom, it was a complete theater of war. What we experienced at that time. So my next question to you will be in terms of making all the funds that were assigned for the marine debris assessment and removal, the repair and replacement of the observing assets, the federal property, mitigation, improve weather forecasting, all those funds that were allocated to the repairs across, not just Puerto Rico, Virgin Islands, Florida, and the rest of the states. All those repairs are being done?
Yeah, we're working according to the spend plans that were submitted to Congress.
So we don't need any more funds for that?
That I can't answer right now.
Okay, that was the point of one of the question directly. My second question will be then, in terms of how can we, if we can elaborate on any other new improvements that we may need in order to have a better position to withstand similar hurricanes affecting same structures. Do we have any other new way to maintain those units in the island?
I'm sorry, are you talking about the means for measuring and providing the information? We are working to build, the capacity of that is always something that we're trying to improve.
Let me better explain what I meant in my question. Maybe we are part of the Caribbean belt, so we're going to be hit. Sadly, I mean, we are in the hurricane area. So this is something that every year we will have our hurricane seasons. My question is, the units, the radar, the Doppler, and all the equipment that we got on the island can withstand another hurricane of the same magnitude? Do we improve the way they were built, or that's something that, of course, may happen?
I'll have to get back to you on the specific specifications for that, but a Cat 5 hurricane
It's complete destruction.
will still have its destructive capabilities, I'm afraid.
Yeah, actually, I agree with you. My question will be if there are any other opportunities that we may have to improve the location of the radars. We do have one in Calle. I know that when you brought one of the radars, you established one in a pilot program in Aguadilla and Roosevelt Roads, and you can come back to me on that. I know my time has expired, so I will submit the rest of my questions for the record. Thank you, and you're back. Thank you.
Thank you. I will now recognize Mr. Caston for 5 minutes.
Thank you, Madam Chair. Thank you to our panel. So when I was starting my career as a young chemical engineer, I had a colleague who used to like to tell a story about a boy who walks by a cave and he sees a dragon, and he taps the dragon with a pencil. The dragon stays asleep. And he said only the dumbest kid on the planet would say, you know what, I can linearly extrapolate that I can probably safely punch the dragon in the nose. I tell that story because over the course of my lifetime, atmospheric CO2 concentrations have gone from 325 to 415, almost 30%, and we have behaved like that dumb little kid. We have linearly extrapolated that first 10 ppm, 20 ppm didn't seem to do anything, and so we've just kept burping CO2 into the atmosphere, and we have now woken up the dragon. The nerd version of this is do not perturb volatile systems. $14 billion weather events last year, wildfires on the West Coast, the bomb vortex in the Midwest, which followed shortly the polar vortex in the Midwest, Midwest flooding. Every year is the hottest year on record. And in a increasingly volatile system, we depend increasingly on having accurate weather forecasting for our farmers, for folks on the coast, folks in, like my daughter, wondering how to seal the door when the bomb vortex was coming in. I am really concerned in light of that history that the Trump FY20 budget request slashes our ability to do weather forecasting. I think it's a 7% total cut. It's a $12.5 million cut in Mesonet funding. Sorry, Dr. Fiebrich. I believe it's a halt in HPC resources for hydrological prediction, which is a concern about Midwest flooding, and almost a 10% cut in full-time employees at the National Weather Service. Dr. Jacobs and Dr. Uccellini, were you consulted on that budget request?
So we spent a lot of time working very hard trying to put this budget together, and in the situation that required really tough choices and trying to balance priorities, we made the decision to implement these cuts primarily on external grants. So we are going to.
But hang on, you say hard choices. Did you make a decision programmatically to cut those services, or were you told to meet a dollar value?
So we have a number that we have to work within, and
No, excuse me, you don't. You can propose whatever budget you want. We're going to decide whether you like it. Did you formally request that budget, or were you told by the Trump administration this was the budget you had to manage to?
so this budget was our formal request.
Okay, so you requested those cuts in programmatic resources.
But these cuts do not pertain to our actual operational capabilities. There's not going to be any degradation in our forecasting capability.
Did you formally model that?
Well, there will probably be a delay in some of the research capability, but that was the reason why we implemented the Earth Prediction Innovation Center. That was an additional $15 million to harness the external development.
No, but hang on. You just said this is not a diminution in the resource. I mean, I heard you talk about the importance of the HPC program, which is being cut. I heard a lot about Mesonet, which is being cut. You're saying that there will be no diminution of our modeling resources. How did you come to that conclusion?
Well, a lot of the research side of the compute we can actually work in the cloud. There's also another thing that we're looking at in the interest of doing acquisition of HPC is a cancellation liability fee. So that's something that's actually
okay. But we're tight on time. I'm asking a quantitative question, and you're giving me a qualitative answer. How do we know on this side of the dais? How does the American public know that in a world with more and more volatile weather, that these draconian cuts to the system are in fact going to maintain accuracy of weather forecasting in an increasingly volatile weather world?
we would not make any cuts that are going to decrease our forecasting skill. How we prove that to you, I suppose you would have to look at our model verification scores.
Can you share that analysis with the committee?
Oh, they're posted online. I can share the link.
If you are wrong, how quick is it to restore those programs?
Well, I'm confident I'm not going to be wrong, so that's a question that I can't answer.
I don't think any of us should be that hubristic, sir. I'm not that confident in my own abilities. Well, if we cut 110 people, how much institutional knowledge is lost? If we are no longer funding the HPC program and all of a sudden a flood comes through that we didn't predict, it's a little late to say, well, Dr. Jacobs said he was confident he wasn't going to be wrong. How do we get that confidence as we sit here and decide what the budget should be?
So these cuts were to extramural grant programs with cooperative institutes and programs like that. We're not making any cuts to our operational capability.
Well,
it's not going to get worse.
My time is up, but 110 employees is a concern. I yield back my time. Thank you.
Thank you, Mr. Caston. I'll now recognize Mr. Lamb for 5 minutes.
If I could just follow up on that same line of questioning, I would just like to clarify because I don't know. I also was concerned that there are such serious cuts in the 2020 budget request. I have a National Weather Service forecast office in my district with excellent employees who just went through a government shutdown and worked without being paid this same year doing work that we all know needs to be done. So let me just make it a simple question. Under your budget request as you see it now, do you believe that there will be any staff positions cut from the National Weather Service office in my district, in the 17th District of Pennsylvania?
No, we're not planning to cut any staff offices or personnel there. We're actually, so this last year was the first year since 2011 that hiring has actually outpaced attrition. If there was a decrease in actual staff, it was because the shutdown happened at the end of the year, and typically people retire at the end of the year. So we have to cover that gap, and we're still in the process of digging out of that hole, but we are certainly headed in a positive direction.
I appreciate that clarification. So you believe that the cuts you have requested would not apply to actual personnel, but would apply to some of these other research programs that you're talking about?
It's on the research side, and I would like to take this opportunity to also highlight the National Blend of Models. I want to make sure everyone's aware that this is not meant to replace forecasters at all. It's meant to be a tool to help them.
I appreciate that. Thank you. Dr. Uccellini, do you agree with that same assessment by Dr. Jacobs, that there will not be a personnel impact from the budget cuts you are proposing?
The budget states that they recognize our desire to apply personnel to this decision support services, but some of those resources will be redirected to other administration priorities.
Would you mind just answering my question with a yes or no? His assessment is that it will not affect staff or personnel in the weather forecasting offices. Do you agree with that?
There is a decrease in the weather service that's applied to the particular part of the budget that does involve personnel. There is still a question as to whether we can absorb that or not with respect to the current staffing levels.
And which personnel would be affected that you're referring to? Which portion of the budget is that?
That's the analyzed forecast support. It's the in the forecast area. So that it's not a large cut, but it's something that we have to look at and apply within that particular portfolio.
Okay, and there are about 434 vacancies at the National Weather Service already?
429.
429, all right. It's moving in the right direction, I guess. My point is this: I've met these people. They live and work in my district. They do excellent work. They absorbed a very difficult shock in their own personal lives when they had to work through the shutdown this year, doing work that the country needs them to do. I think they deserve a little bit of clarity on whether they're getting help inside their agency or not. Many of these people feel overworked. They're working additional hours. Now they realize that the administration that oversees them is proposing cuts to their agency, and we're getting two different stories on whether those cuts are going to affect the personnel situation at that office. So I would request that the two of you communicate over exactly what's happening here, and if you can follow up with us on exactly what the personnel impact of these budget cuts would be. I think we all want to know that before we render a decision on what we think of the budget request. And with that, Madam Chairwoman, I yield back the balance of my time.
Thank you very much, Mr. Lamb. And I want to thank all of the witnesses. This has been such a good panel that your prize is a second round of questions from members of Congress. So we agreed up here that this is something we all would like to follow up on, a few other things. And so I'm going to first yield myself an additional 5 minutes to ask questions. And I want to do a quick follow-up on the budget. We've already had a budget hearing, but I did want to follow up as we talk about funding levels, about making sure that our communities are equipped with an accurate hurricane forecast as we head into hurricane season. That is the number one concern in my district. I represent Houston, and we, of course, were impacted by Hurricane Harvey. So on the budget question, I just want to ask you, Dr. Jacobs, to follow up. Can NOAA ensure that our communities are equipped with the best possible hurricane forecast given the funding cuts in these areas?
There's not going to be any degradation to the forecast skill.
Okay. And then my other follow-up question, before I was asking And Dr. Uccellini had a chance to answer my question, but would anyone else like to comment on mechanisms for collaboration and communication between the members of the weather enterprise? I think I cut off some potential answers in the last round, so would love to hear from you, Dr. Chen, from Mr. Sorkin, anyone who wants to weigh in on this.
Thank you for the question. If I may, I would like to address several questions that came up during this hearing, specifically addressing to Chairwoman your question about how we best go forward. One of the difficulty right now is our enterprise have this very broad, complex needs for the society service. So currently, we have, like NOAA and some other agencies, the budgetary priority is set year to year. And sometimes we are put in this reactive position, which something that National Academy has been proposing this study to look long-term, how we best ensure these weather extremes and in the changing climate that will benefit society the long term. How do we best position ourselves, forecast weather from the very high resolution, like resolving Harvey, flooding, and also if you probably recall, during Harvey, much of the flooding was due to rain. Storm surge blocked drainage. Also the built environment that actually blocked the drainage from down to the ground. So these are very challenging things. So in my third part of the testimony, we asking possible Congress help. So I think you can really help to organizing this enterprise, look 10 years, 20 years down the road. We have a very successful models to do this before. The decadal survey from the Earth observing from space just published the last year, that map out very long-term, 200 scientists involved in developing that plan and take a long-term vision to plan. So this way, if we have something like that in the weather enterprise, we can best organize our entire country to take a long-term plan. We do not have to do this reactive thing that year to year that put us in this very difficult position. I'm pretty sure the whole country will be serving well if we have a weather like a decadal or 20 years from now, we can start acting now and continue to meet our challenges.
Thank you, Dr. Chen. Mr. Sorkin?
Thank you. Jupiter looks at this question from several perspectives. First, our current product. Second, our product roadmap. And thirdly, the difference between universities and the public sector. With regard to our existing products, the company is 2.5 years old. We deployed our first service in under a year, and part of that was through collaborations with university partners in New York. That included Columbia University and Brooklyn College, where we identified very specific scientific expertise that we wanted to leverage into our commercial services. We've done the same thing with Rice in Houston, and similarly in Florida and around the world. Secondly, from the perspective of our long-term product roadmap, so say 3 to 10 years, we identify emerging science that we believe will have a positive impact on the predictive quality of our services for protecting life and infrastructure and continuity of mission for things like hospitals and roads and hotels and power plants and the like. And there, we talked earlier about cloud computing. One of the things that we're working quite aggressively on is helping our university partners access cloud compute resource, integrate into our operational infrastructure, and test the models even before they're ready for operations to accelerate the research to operations process. We can do that because we're very targeted on a specific set of customer solutions, and work backwards from that to the short-term and medium-term science that's required. From a government perspective, we have a very good dialogue with our colleagues at NOAA, and I think they're the best, most useful thing from a NOAA perspective is transparency on the existing scientific road priorities, as well as what's coming down the pike, both internally within NOAA and from a scientific funding perspective. I think they do a good job on that, and we'll continue to work closely with them to better understand what's coming down the road to deliver these risk services in places like Houston and Texas generally.
Thank you, Mr. Sorkin. And I've once again gone over my time. I'm going to recognize Ranking Member Lucas for 5 minutes.
Thank you, Madam Chair. Dr. Jacobs, let's talk for a moment more about the spectrum issue. And at the conclusion, I'd like to offer an observation or two about the budget process. And question to you, sir, while we wait for the public release of the NOAA-NASA study, can you explain the process you used to validate the study?
So typically, we would take these algorithms, we would use a baseline set of assumptions, first testing things that are known quantities and reproducing outputs that are known. That's how we actually verify the code. The actual subject matter experts, this was validated with NOAA subject matter experts. It was concurred with the Navy, and then most importantly, validated by the subject matter experts in NASA. And this is an agency that sent a man to the moon 50 years ago using calculators. So I would certainly trust their input. But just to convince myself, I actually got a copy of the MATLAB code myself. And I can tell you it's fairly straightforward. You don't even need to compile it. You just have to have MATLAB and the right toolboxes.
So you don't even need a slide rule to do that.
Or an abacus.
Thank you. Dr. Jacobs, also, would you describe the time frame of NOAA's interaction with the FCC leading up to the March spectrum auction?
So we had assembled subject matter experts from NOAA, NASA, and the FCC as far back as 2017, going back and forth on the studies. There was an original study. There was a lot of questions about the assumptions that went into the software, which was a prepackaged software, which is relatively black box. You couldn't look at the source code to determine anything from it. So the FCC requested that we reconduct a study with code that you could actually see, and you could actually change the input parameters, which was a valid request. So we redid that. That began, I believe, somewhere last fall, November, December timeframe. Then we had the shutdown. On the heels of the shutdown, we reconvened, and at that point had output and have been going back and forth with the FCC ever since, where their subject matter experts are proposing new assumptions or questioning the inputs, and then we rerun the study with those inputs and come back with the results, and we're still sort of stuck in that do loop, so to speak.
The public would call it running the timeout, so to speak.
Well, we haven't seen anything that has been proposed by the FCC as far as assumptions that have changed the results of the study thus far.
So you're comfortable in saying that NOAA's dotted all the I's and crossed all the T's in preparing this information?
I'm confident that the study is acceptable.
Thank you, Doctor. And let me touch, for the benefit of my colleagues, a little bit on the budgeting process. Having been around a little while, I've discovered that generally when an executive budget comes down, the only thing that's ever recognized by people is when on the rare occasion an administration asks for additional spending, then we tend to respond to that in Congress. That was a weak attempt at humor, but a factual statement nonetheless. Typically, presidential budgets, executive budgets, are something that are required in the 1974 Budget Act and are examined and set aside. The 74 Budget Act gives the United States House, the United States Senate, the responsibility, yes, to look at the president's executive budget, but to craft our own and to reconcile that final document and use that as the product for the appropriation process to move forward. While we have an executive budget that many of us find fascinating, I think the focus of this body should be, how do we persuade our friends on the Budget Committee to do their work so that we'll have a real document that the appropriators can move forward with and fulfill all the responsibilities of the 1974 Budget Act. So while I, like many members, have typically been underwhelmed by the executive branch budget, whichever administration offered it up, the real onus is on us to do our work, and we should try harder to do our work and fulfill our responsibilities. With that, I yield back, Madam Chair.
Thank you, Mr. Lucas. I'll now recognize Mr. Tonko for 5 minutes.
Thank you, Chairwoman Fletcher. In May 2017, a Government Accountability Office study confirmed the vacancy rate in NWS operational units has already reached a point where NWS employees are, and I quote, unable at times to perform key tasks. According to the GAO, NWS managers admit, and again quote, that employees are fatigued and morale is low, and that employees, quote, were demoralized because they had to cover the workload for multiple vacancies. Service assessments, which the NWS itself conducted following 12 major storms that occurred between 2008 and 2017, found that the ability of the NWS to protect lives during these major events was compromised due to already inadequate staffing at critical forecast offices or river forecast centers. Yet the administration has now proposed to cut 20% of all the forecasters at the nation's 122 forecast offices, as well as close an unspecified number of forecast offices at night and on weekends as a result. The President's NOAA budget request admits that these closures are a potential risk to the public and partners. Now, how do we reconcile these cuts with the stated reality that we are hearing from forecasters?
Well, since May 2017, we've actually focused our hiring on entry-level meteorologists and hydrologists, and we track every forecast office in terms of the availability to cover shifts and do the other tasks. And we're in a better place now with respect to that than we were in May 2017. I'm not aware of any plans to part-time offices, as it's called, nor or shut down any offices. So I'm not sure where that's coming from, but it's certainly not in any of our plans.
And in terms of vacancies, the number again?
The vacancies we have right now are 429 compared to the appropriated level. In other words, we just heard about the budget process, and we actually staff according to what is appropriated. So that's 4623, and right now we're looking at 429 vacancies, and we have about 301 hiring actions going. I should also note for this year, having that 5-week shutdown has had a major impact on our abilities to sustain the momentum that we had going into December of last year. So we are concerned about what it is not just a light switch that you turn this process back on and the same people are waiting in the waiting there to be brought on. A lot of the people don't stay within that process once it's shut down. So we do have concerns for the very near term because of that, but we were on an upward trend, and that focus that we had was on the entry-level meteorologist to account for what you reported on from the May 2017 report.
Right, and I know that the executive budget is something that we need to work away at, but a starting point is always an important factor. And with all of these vacancies, it would have been good if we have an executive that believes in climate change so that the numbers in a budget presented from the executive branch would reflect that in the budget planning that is envisioned for the agency. I've also heard concerns that NWS forecast offices may be reduced, and these offices may no longer operate 24 hours a day or 7 days a week. Are any such plans being studied, developed, or implemented by NWS to reduce the hours of operations at our NWS forecast offices?
So what we have seen in analysis and experience over the past 2 years is that in meeting the needs, increased needs as specified in the Weather Act of the Impact-Based Decision Support Services, the forecast offices are taking on increased importance in our ability to do that. So I can tell you that within the Weather Service and NOAA, that we are working towards actually supporting those forecasters to meet those increased needs. And we've listened to the emergency managers who have expressed the same concerns over the last several years, that we're working with them, and they're asking for 24/7 with respect to those local offices. But how we manage the resources within those offices is something that we have to do within what's appropriated to us.
Well, in dealing back, I would just ask that you indicate which sites are, if they are going to be considered for reductions, if you could share that information with the subcommittee, that would be important. And with that, I yield back, Madam Chair.
Thank you, Mr. Tonko. I'll now recognize Ms. Gonzalez-Colon for 5 minutes.
Thank you, Madam Chair. And again, I couldn't finish to say thank you to the agencies that help us out in the moment of need. And I mean, all of your agencies went beyond and above to put us in place after the hurricane. And one of the lessons that I want you to tell me about is about the cooperating relationship between the federal agencies and the private sector to make things happen after the hurricane. Because without communication, without the radars, without a lot of the assets on the ground, in our case, I know you came together with the Department of Defense, the Marines, the agencies itself, and even the private sector to make things happen. My question will be, are there any lessons that we need to put into law or in an agreement with the private sector as well in order to face this kind of a emergency situation from now on?
Well, one of the lessons, first of all, we're working in partnerships with the federal agencies. We recognize that in terms of making the forecast and providing it for decision-making, we can't do that alone. And clearly, there are other agencies that are actually on the ground, either preparing a location for an extreme event or responding to it, or working after to restore. So a component of NOAA, the National Ocean Service, spends a lot of time working to restore the coastal areas and the harbors, as an example. With respect to the private sector and the nonprofits, which are playing an increasingly important role, many of those people and organizations are part of the Weather Ready Nation ambassador number that I spoke to. And we work with them from a public safety perspective throughout the year. So there's a basis there to be working from, and there's a lot to learn. One of the learning experiences from that hurricane season was many of us prepare for a worst-case scenario of one Category 5 storm. What if you have 2 Category 5 storms? So one of the tragedies with respect to Puerto Rico was the aid that was on its way had to turn back because there was even another storm coming in after the destructive storms that hit that area. So we're always there to learn from these events, but we are working together in a much better place than we were 5, 6, 7 years ago.
My second question will be and we saw that in the happening. So it was not, I mean, we got FEMA and the federal agencies on the island before, during, and after the hurricane. That never happened before. So I thought that was a better coordination before the hurricane hit us and better information of the forecast. People they knew what was happening because we got the data in time. And that's, I think, the most important thing in terms of that forecast, the weather forecast for not just for Puerto Rico and the Caribbean, the whole nation. And in our case, it was the system that you install helped us out, not just Puerto Rico, the Virgin Islands, and the rest of the small countries in the Caribbean that were using actually that data when they were cut off from their communications. During the last Congress, we approved $120 million for operations, research, and facilities. Of those, more than $40 million for charting, mapping, improved weather forecasting, $50 million, $79 million for procurement and construction, specifically 29 for repairs in many areas. Before this turn, I make the question if we need more resources in those areas, if we fall short to making those repairs at that time, and if there's anything else that Congress can do. And I completely agree with Mr. Lucas, and actually I want to thank him for making the legislation possible of the Weather Act more than 25 years without having a comprehensive law that can permit forecast this kind of issues. If there anything else that you can recommend us, and thank you, Dr. Jacobs, for your work in the agency as well. Dr. Chen.
Yeah, if I may add a point to that. So former FEMA director Greg Fugate always pointed out that with all the heroic response to emergency, we, really grateful for these. But on the other hand, he will always remind us we got to that situation tells us we haven't prepared ourselves. We should try to prevent these things to happen in the first place. So this brings me back to this long-term planning in terms of a future climate change. With the sea level rises, hurricanes only going to be much more destructive. So how do we prepare ourselves for the situation that avoiding the current situation, reacting to each storm the way we are? So that is the goal of the national priority, and I think Congress can help us to take a long-term approach. We don't want to put our society in that vulnerable position year after year. Thank you.
Thank you.
Thank you, Ms. Gonzalez-Colon. I will now recognize Mr. Babin for 5 minutes.
All right, thank you so much, Madam Chair. I'm sorry I'm running a little bit late today. And thank you. Thank you, witnesses, for being here. Dr. Jacobs, I'd like to ask you the first question. In addition to serving on this subcommittee, I'm the ranking member and former chairman of the Space Subcommittee. NASA manages the development and launch of the reimbursable satellite programs, projects, and instruments for NOAA through the Joint Agency Satellite Division. One of the programs they develop is the Joint Polar Satellite System. JPSS is an $11 billion investment from taxpayers in our weather observation capabilities that protect lives and property. These satellites provide the bulk of the observations needed to make our medium and long-range weather forecasting successful. 85 to 90% of all data that's used in numerical weather prediction models come from polar orbiting satellite data. One of the most important measurements that JPSS makes is microwave sounding. Recent reports indicated that the FCC's 24 gigahertz auction would effectively jam NOAA's use of that spectrum for microwave sounding that serves as the very backbone of our weather prediction capabilities that protect lives and property. If appropriate protection limits are not placed on the use of the spectrum sold at auction by the FCC, should NASA and NOAA issue stop work notices to contractors on JPSS?
Well, we're still in the process of working with NOAA, NASA, and the FCC to hopefully reach a solution that we can all live with. But with the ATMS instrument on the current JPSS as well as the proposed JPSS 2, 3, and 4, the mission requirements are 98% data. So if we see a projected loss of 2% or more, then it's highly likely we would issue a stop work order.
Okay. And if NASA and NOAA continued to fund the development of JPSS that are effectively unusable as a result of the FCC auction, could this constitute a misappropriation of funds by these agencies?
Well, it probably would not be the best use of taxpayer money if we were paying for instruments we couldn't use.
Right. Okay. Thank you very much. And also, again, Dr. Jacobs, listening to the testimony from our panel, it seems that NOAA has a lot to do in order to take the next step in improving weather forecasting. From my vantage point, this should be among the agency's very top priorities in the coming years. Years ago, the Office of Space Commerce and Office of Commercial Regulatory Affairs were buried in NOAA. Do you support consolidating them and moving them back to the Department of Commerce, where they were originally placed by statute in order to allow NOAA to focus on its core mission?
Yes, there's a lot of different bureaus within the Department of Commerce that would equally share and be very benefited by this being at the DOC level, so yes.
Excellent, thank you. And Dr. Uccellini, is that it? Okay, thank you. As you are aware, the Congress appropriated a great deal of additional funding to the National Weather Service after Hurricane Sandy. This money was intended to help the Weather Service improve its hurricane models for future cycles. As a member representing a district that was hit hard, very hard, by Hurricane Harvey, can you imagine, or excuse me, can you explain how this additional funding made a difference in forecasting, and what should the Congress do to improve severe weather prediction capabilities for future hurricane seasons?
So, first of all, thank you for the support after Sandy. That covered a whole spectrum of activities, including numerical modeling for the Hurricane Forecast Improvement Program, and an operational computer that allowed us the capacity to actually run the model operationally that the research community could transition as part of the R2O. When it came to Harvey, Harvey was a tricky storm up front when it was developing near the Mexican coast, east of the Yucatan Peninsula. But first of all, the global models started picking up on that this storm would not only be moving towards the northwest, towards Texas, but also intensifying. But it was the new hurricane, what we call the HWRF, the new finer scale hurricane model that picked up that this storm would rapidly intensify as it approached the coast. And it was one of these nightmare scenarios that storm actually intensified from a Category 2 to a Category 4 as it was approaching the coastline. We were ready for that, and up to a certain amount. I don't think we quite had the 4, but we had that it was intensifying as it approached the coast. The reason this was important was that we were co-located, we were embedded with the emergency management community at Corpus Christi, and we were briefing them on when they would be able to go out and rescue people and when they would not, because this was not going to be a storm that they wanted to be out on the outer islands for. So we actually worked with them, and when between the satellite data, first of all, the models, satellite data, and radars, they actually went out during the eye, when the eye wall passed over the coast, and went out and rescued over 250 people and brought them back before the back wall came in. So all things mapped out, the modeling component of that sequence was actually the benefit of Sandy supplemental funding.
Great, I really appreciate that. And I'll yield back my negative amount of time. Thank you very much. Thank you.
Thank you, Mr. Babin, and thank you to all of our witnesses for coming today and hearing us out and answering not one but 2 rounds of questions. You have a special distinction now in this committee, but I really appreciate the testimony. It's very helpful, and this is a critically important issue. The record will remain open for 2 weeks for additional statements from members and for any additional questions from the committee to the witnesses. With that, the witnesses are excused, and the hearing is now adjourned.
Thank you.